Alright, so here's my actual effort. Obviously no one's in the class at the moment because I didn't record it during class, but you guys seem to understand it pretty well, so here we go. So locus, or loci, which is the plural, is Latin for the location or the place. So in other words, all we're trying to do is a loci is a set of points that satisfy certain conditions. In other words, in year 11, you had to draw that loci. In other words, you draw that, you'd go, okay, it's got a y-intercept of 3, it's got a gradient of -2, so there are some points on this graph just there. Now, as I said to you during class, is that a line? And you guys said, no, it's just a whole bunch of little dots joined so close together that they turn into a straight line. And that's what these loci are. They're a whole bunch of points. They're a set of points where the location is described like a graph. Okay, so there's a loci in year 11 terms. What about year 12? Okay, so year 12, what type of graph is that? You guys said it was a circle. So it's got a radius of 5, 1, 2, 3, 4, 5, and a center of 0. So I'm just going to, from my 0, 0 origin, there is my, excuse me, but there's my circle. Please just believe that's a circle. Happy with that one? What about the next one? How do you draw that circle? Okay, well, this shifts the center to the right 3, and that shifts it down 2. That gives me a radius of 3. So, to the right 3, down 2, there's my center. Radius of 3, down 2. Can't count, down 2 there. Radius, 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 and there is my circle. Again, are we drawing a line? No, it's a whole bunch of points that, when enough are there, looks like a circle. Okay, so year 13, year 11, year 12, we were talking about an x and a y plane. Year 13, what are we doing? Well, we're talking about complex numbers, so we're not actually talking about an x and a y plane. We're talking about generally going to be a real and an imaginary plane. Okay, so here's this real part. So 2 lots of the real part plus an imaginary part is 4. So what could we draw? Okay, so let's come up with some points. Almost like, rather than it being an x and a y table, it's like a real part and an imaginary part. Okay, so, and all these two have to do is add up to 4. Okay, so 2 real. So let's say the real is 0. Real is 0. So 2 lots of 0 is 0. So the imaginary part has to be 4. So when real is 0, the imaginary part up here is 4. When the real is 1, 2 lots of 1 is 2. So the imaginary part is 2. And the real part is 2. 2 lots of 2 is 4. So the imaginary part is 0. Okay, so, and this just forms, you know, if the real is -1, then the imaginary part is 6. If the imaginary part, if the real is a half, then what is the imaginary component? Well, that's just 5. Sorry, -1/2 I meant. I was thinking about there. There's 5. A half would be 3. And again, it's just this whole bunch of dots along that line there. It's the whole set of dots, it's the whole set of points that actually form that straight line, which is what you're talking about. Okay, so stepping things up a notch, as I said in class, what is this again? It's the modulus. Okay, so can we draw something with a modulus of 5? Okay, well, this has got, there's a complex number with a modulus of 5. There's a complex number with a modulus of 5. There's a complex number with a modulus of 5. And there's a number with a complex number of 5. Sorry, there's a complex number with a modulus of 5. 1, 2, 3. There's one there, and there's one there as well. Here's another one. Here's another one. Here's 3, 4, 5 triangles. There are a couple more. 3, 4, 5 triangles. There are a couple more. So in other words, anywhere along around that circle is where there is a modulus of 5. That's it, and that's a Loci. That is that Loci. So we went a bit. We had a look at that a bit more detail. So we had, okay, if this is a circle, it's got a center of 0, 0, radius of 5, then this here is just the difference between our complex number and the fixed center point of a circle. Okay, so in other words, drawing this one here has a modulus of 4, so that gives us our radius of 4. So there's a 4, there's a radius. We've got to find the center. How do we find the center? Well, from this formula here. So in other words, this part just here, z minus 5 plus 3i, okay, that part there, that should be a modulus sign, sorry, that can be written like z minus z1. Well, if it's written as z minus z1, then that's just z minus 5 minus 3i. Because if I expand that, I get the left hand side there. So in other words, now here is where my circle has been moved. There is the center of my circle. So it's at 1, 2, 3, 4, 5 and down at 3. There's my center of my circle. Oh, it's got a radius of 4, so I just go up 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There is my Loci for this particular equation. Okay, hopefully that makes sense. Now what I got you to do in class is, okay, thinking, now remember this is talking about on the real and imaginary planes. Okay, but what if it wasn't the real and imaginary planes? What if it was x and y? What would that equation be on an xy plane? And most of you were quickly able to say, okay, so that's going to be x minus 5, because that's how you move it to the right, squared, plus y plus 3 squared equals 4 squared. And then I said to you, well, do you see the similarities there? You know, so minus 5 with the x. Next part, starting to fail on me. This positive 3 here with the y plus 3 there. This 4 becomes there. That is the radius squared. And so now if I ask you to draw loads and loads of, like if I ask you to draw this one, z plus 4 minus 2i equals 3. What you should be able to do is tell me that the equation in x and y in the, what we're going to call is the Cartesian plane, rather than the Argand diagram or the complex Argand diagram or the complex plane, would be x plus 4 all squared plus y minus 2 all squared equals 3 squared. So in other words, that circle is moved to the to the left, 1, 2, 3, 4, and up 2. And that's where it is. It's got a radius of 3, so we go down there, we go there, we go there, we go there, and there. Excuse the drawing, that's real bad even for me. There is my Loci. Hopefully that makes sense, and that's where we left it yesterday. Okay. Now I'll make the video now. I'll carry on with it now. We can just talk about it tomorrow. But if that's what you're doing, when you're getting into the exam style questions, that's been in 2016, 2017. What the important thing to be able to realize is that this here can be written like this. More importantly, I'll just rub those two out. This, you need to be able to express that as the square root of that. Take out that squared. So this part here can be written as all of that. Why? Why you say? Well, hold on. Well, this here, remember, this was a circle. The modulus is 4. There's a circle. The modulus of this one, well, that's just the square root of x minus 2 all squared plus y plus 3 all squared is the same as the modulus of x minus 1 squared plus y squared. Wait, what? So remember what we were doing, and I'll just pause it. So I've just paused it and given myself a little more space and drawn a little graph there, okay? So this is just a circle with a center of 2, -3, so it's down there. The next one is the center of a circle, 1, 2, -3, yep, center of the circle where it's just there. Now, it doesn't talk about a radius in particular, so if I had a circle with that as a center, where is it the same as that? And we're going to talk about all those 2 points just there. Again, this is where you guys laughed at me because my drawing was terrible. We had a bigger circle and another bigger circle. Where are they the same? They're just there and there. Again, I could draw a whole bunch more, but what they should all do is line up on a particular line that is a perpendicular bisector. Perpendicular bisector, basically saying they are the same distance. Every single point on this line is the same distance away from either of those 2 points. They're called equidistant away. Okay, so in other words, that's what we're trying to do, is we're trying to solve this equation just here. So let's move it over here, give ourselves some more space. So how would you solve that? Well, as I did in class, I just went, well, let's square both sides. With x minus 2 all squared plus y plus 3 all squared is x minus 1 all squared plus y squared. And I'm running out of time, so I'm just going to cut it short. I'm just going to expand these brackets. So expanding those brackets, now what I'm going to do is I'm going to collect my like terms. So I'll cancel one out, x over here and x squared over there, y squared and y squared here. Here I'm going to combine this 4 and this 9 to be 13. So now on my left side I've got -4x plus 6x plus 13. Sorry, that should be a y, shouldn't it? Apologies, that should be a y. And this should equal -2x plus 1. Take everything to one side, gives me 6y minus 2x plus 12 equals 0, which is actually the same as, hopefully if I did this right, 3y minus x plus 6. I'm running out of time, so that's why I'm potentially making a few more mistakes. Okay, which as I write like y equals mx plus c gives me a gradient of a third, which is what the question was asking, gradient. There's my Loci complex 2016 question.